Okay, so they want me to get the shaded region, and that's that little pinkish area there. And kind of looking at it, they tell me what the curves are. They tell me the main circle is r equals 1. And then they tell me this other circle is r equals the cosine of theta minus sine theta. And I'm seeing that. What I'm going to kind of do is look at it and start talking about where these two curves are intersecting one another. So I'm going to say over here somewhere. All right. So if I were to write that down, looking at it, I don't know. Let's take a look at that one. And I'm going to say, I don't know. Let's talk about this thing as being some angle theta at this point where it's starting. And to look at that, I'm going to say it looks like theta is going to be 0 there. And, if I did that, the r is always going to be 1 in the red circle. Let's look at the blue circle, though. What are you going to get? What's the r going to be over there? And we're doing, this is a polar equation, by the way. It's going to be cosine of 0, which is 1, minus sine. Yeah, it's 1. Looks pretty good. All right. Going to keep going along. Then the next thing I'm going to ask question is, I'm wondering where this occurs over here. And where does that occur? Well, it's on the blue curve. It occurs when theta is equal to pi over 4. And why is that? Well, the cosine of pi over 4, this is r, by the way, would be 1 over root 2. And the sine of pi over 4 would be 1 over root 2. So definitely get the 0 there. I got that. So this over here, this theta over here is right there. This is going to be theta equals pi over 4. All right. Now let's keep moving around. And I'm going to go to like pi over 2 now. Theta equals pi over 2. All right. Now pi over 2 is up here, that up there. But I'm wondering what this gives me over here. And let's write this down then. So what are you going to get? You can get r equals, well, the cosine of theta, if theta is pi over 2, would be 0. And then I get minus the sine of pi over 2, which is going to be 1. So what do? It's actually, again, we're up here, but I got to go in the opposite direction, so I'm over here. So where does this occur? This occurs at pi over 2. Again, I'm going to keep moving along as I do this over here. My question is, when does it go back there again? All right. So I'll write that down for you, and that's going to be. I'm going to say, when does the? Well, take a look at that. So let's see, pi over 2. I'm going to say 3 pi over 4. Let me see if I said that right. No, I'm sorry, that's not right. Let me just see if I'm counting it right. So pi over 4, I'm sorry, I made another mistake over here. I just noticed it. Let me erase. Good to make mistakes. You have to think about what you just said. So this is where theta equals 0. Sorry about that. This is over here where theta equals pi over 4. Now we're at pi over 2. And I want to get over there, which is going to give me a 1 again. And I'm wondering when that's going to do that for me. And let's see, I'm at pi over 2. And I'm going to say, let's see what I want to get. I'm going to go to pi. All right, let me put that down. So I'm going to put pi down. Theta equals pi. And by the way, pi's over here. And I want to see what happens, though. And what happens over there? Let's be careful now. And what are you going to get? Well, r, the cosine of pi is minus 1, and the sine of pi is 0. So we get minus 1. So what does it mean? Well, let's take a look. I'm at the, let's see, I'm at pi, right? I'd be at minus 1, so I'm at this point over here. So what I'm going to say is over here, this thing here is occurring between pi over 2 and this over here is pi now. All right, that's what the theta is. So I think I'm kind of clear on this. Let me get my eraser out and erase all this business over here. I got my starting position and my stopping position. Hope I can remember that, right? I'm going to start writing my integral down. By the way, I said it was okay to use a calculator. All right? And I'll write it down for you. So what do I get over here? I get pi over 2 to pi. And what am I going to do? I'm doing this thing over here. I'm kind of doing this arc over here. And I know how to do that, by the way. What's it going to be? 1/2. Let's see, 1/2. Let's see, theta r squared. All right, let me write that down. So it's going to be cosine theta minus sine theta squared d theta. But you know what? I got to take away this business over here, by the way, which looks pretty easy for me, by the way. Really, I don't have to do an integration for that. What's it going to be? It's going to be a quarter of a circle of radius 1. So it's going to be 1/4 pi r squared, which is 1. So 1/4 of pi. So I'll write that down. So I subtract pi over 4 from this. All right? Now, by the way, they say you could use a calculator, and that's fine. But the problem for me always is writing down what the integral is. And we did that over here. Let me point that out to you. I got this written over here, cosine theta minus sine theta, d theta minus pi over 4. And by the way, if you use the calculator, you should get a half. I do want to go through the work, by the way. All right? Now, why do you want to go through the work? I don't think a calculator should be used in a problem like this. However, according to this guy's exam paper, he wants you to use a calculator to do that. I just don't think it's appropriate, by the way. So what I want to do is I want to go through the work, and I'll do that for you. And I'm going to say 1/2 pi over 2. Let's see, pi. I'm going to expand this. What do I get? Cosine squared theta plus sine squared theta. And then I'd get, let's see, minus 2 cosine theta sine theta d theta. Let's see, minus pi over 4. One thing I like about this problem over here is it looks kind of simple to do. Like, for example, this is a Pythagorean identity. I'll write that down for you. So I get 1/2. This is going to be pi over 2 to pi. And then what do you get there? I get 1 minus 2. Well, you know what? I think I can write that a simpler way, right? So 2 cosine theta sine theta is just actually sine of 2 theta. D theta minus pi over 4. Let me keep going through that. It's 1/2. What's the antiderivative of 1? It's theta. What's the antiderivative of sine of 2 theta? That would be, let's see, plus the cosine of 2 theta over 2. The limits of integration will be pi over 2 to pi, and then minus pi over 4. Let's just be careful with this. It's going to be 1/2 pi. And then, you know, the cosine, that's going to be 2 pi, so that'll be 1/2. Minus 1/2. We can get pi over 2. It's kind of nightmarish, isn't it? Plus, well, the cosine of pi would be minus 1, so minus 1/2. And then minus pi over 4. Let's keep doing this. This will give me pi over 2 plus 1/4 minus pi over 4. Let's see, plus 1/4 and then minus pi over 4. Oh, geez, more arithmetic. Well, 1/4, let's see if I did that right. 1/4 and 1/4 is 2 quarters, which is 1/2. I got this covered. And then this added to that would be minus pi over 2, so it's 0. So what's the answer going to be? 1/2, as they say. Here's the deal, though. They said use a calculator. I would use a calculator. I wouldn't have gone through that to do that. Thank you.